Next, let's look at a second example. Example 2. When we roll a die twice, and we are interested in the total of spots resulting, we call this variable y. Okay, we call this variable y. In this picture, on the first row we find spot 2, second row we find what? Spot 5. So y is equal to y1 plus y2. It's a sample total, or we say this is a sum of spots what? Resulting. On the first row we see spot 2, second row we see spot 5. So 2 plus 5 is 7. So sample total is 5, or we say the sum of spots resulting is 7, sorry, okay? So the sum of spots resulting is 7. Now what is yk? I use y1, y2, what's yk? Yk is a spot shown on the case row, okay? On the first row I see spot 2, so this is 2, y1 is 2. And second row I see spot 5, so y2 is what? Is 5. So 2 plus 5 is 7, okay? Now, how can I use a box model to specify the given random experiment? A given model for the random experiment, okay? Random experiment 2. Let's look at random experiment 2. How can we use a box model to represent random experiment 2, okay? Now, first one, what number go into the box? We know a die has what? 6 faces. And on each faces, you're going to find what? Spot 1. One face you find spot 1. The other face you find spot 2, spot 3, spot 4, spot 5, spot 6, and so on and so forth. Okay? 6-sided die. So you have what? 6 different spots. Spot 1 to spot 6. So what number go into the box? Okay? 1 to 6. And to show the given die is a balanced die. So each one is what? 1, 1, 1, 1, 1, 1. Okay? One number go into the box. 1 to 6 go into the box. How many each kind? Each one is 1, 1, 1, 1, 1. Okay? So that is to show how likely we're going to see spot 1. The chance is 1 over 6. How likely we see spot 4? The chance is 1 over 6. And how likely we see spot 6 is also 1 over 6. So you can use either 1, 1, 1, 1, 1, 1, or you use 1 over 6, 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 1 over 6 to specify the given die is a balanced die. And how many draws? We roll the die twice. So it's like we make what? 2 draws from the box. And this is again with replacement, okay, with replacement. Because on the first row I see spot 1, second row I can still see what? Spot 1. So it's still what? So this one should be what? With replacement. Okay, let's look at the comments. Now, this box is a non-zero one box because it's not just only 0 and 1 go into the box. You find 1 to 6. So this is not a 0, 1 box. We call non-zero one box. And sometimes I call non-zero one box a sum box. Okay? Now, second one. Y divided by n. Y is what we call sample total. Sample total divided by sample size. This is how we define what? Sample mean. In our example, y is 7 and n is what? 2. Y is y1 plus y2. 2 plus 5 is 7, right? And n is 2. The sample size is 2. So 7 divided by 2 is 3.5. So the sample mean is 3.5. The 3.5 is the sample mean. Some book use what? Y bar to specify Y over N. And C, in most real-life applications, we use Y bar to estimate mu Y. Mu Y is the population mean, okay? Mu Y is the average of what? The box. This is a sum box. So mu Y is average of what? Sum box. And in our case, 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by 6, which is what? 3.5. And this is what we call population mean. Okay, this is what we call population mean.